they have given an electric bulb. The electric bulb is rated 220 volt, 100 watt. What is the resistance? Watt is a unit of power. This is what maximum voltage it can take. That is 220 volt it can take it. And the power of the bulb is this. And R is the resistance. Very important person only, VIP of power. Voltage is 220. Current, what is the value of current? You don't know. Power is 100. Therefore, current is 0, 0 get cancelled. Current is equal to 10 by 22 ampere. But you know the formula, V is equal to IR. Again, V is 220. I is 10 by 22 R. 0, 0 get cancelled. R is equal to 22 into 22. Now the value of resistance. Now you have got it. How much? The value multiply just so much ohm. Here you can use other formula also. What is the other formula you can use? 22 into 22. You'll get about 484 ohm. Or 0.484 into 10 to the power of 3 ohm or 0.484 kilo ohm. You can do it. Right? Next, 1 kilowatt hour is equal to so much joules. Kilo is 10 to the power of 3. Watt is joules per second. Hour 60 into 60 second. 1 hour. Second get cancelled. Here 10 to the power of 3. Kilo means 1000, isn't it? 10 to the power of 3. Here 6 6 are 36 into 00 kilowatt hour. Therefore 36 into 10 to the power of, this is 10 to the power of 2, 10 to the power of 3, 10 to the power of 2, 36 into 10 to the power of 5. You know the formula, a to the power of m, a to the power of n is equal to a to the power of m plus n. 10 to the power of 3 into 10 to the power of 2 is equal to 10 to the power of 3 plus 2, 10 to the power of 5. Or 3.6 into 10 to the power of 6 joule, 1 kilowatt hour. 1 kilowatt is what? Commercial unit of electric energy. Okay. Now there is another problem. They may ask you, suppose 1 by 5 ohm, 1 by 5 ohm, like this. There are 5 resistors are given. 1, 2, 3, 4, 5 resistors are given. Which combination? What is the maximum value of the resistance? Which combination give maximum value of resistance? Let me put, let x is equal to 1 by f. All are x. Okay. Each value is x. What is the RS value? RS is equal to x plus x plus x plus x plus x. Therefore 5x resistance in series is equal to 5x, or 5x is equal to 1 by 5, 1 ohm. The resistance in series, effective resistance is called 1 ohm. Now what is parallel combination? Reciprocal of effective resistance, the parallel combination is equal to 1 by sum of the reciprocal of the individual resistance and so on. Here 1 by x plus 1 by x plus 1 by x, 5 times, right? I'll write it. Therefore 1 by Rp equal to 5 times 1 by x or 5 by x. If you reverse this, Rp is equal to x by 5. And what is the value of x? See, this is 1 by 5 into x, isn't it? This is 1 by 5. X is 1 by 5. Therefore, Rp is equal to 1 by 25. Now this 1 by 25 is equal to, say, suppose 4 multiplied by 4, both this 4 into 25, 4 by 100, 0.04, right, or very minimum value. Therefore parallel have 0.04. This is minimum. The maximum is this. Some students, see, this is for multiple choice question. This is multiple choice question, only 1 mark in 10th standard. And what are the other possibilities you can think? Next year, see, what are the other possibilities you can think? Say, two series, 3 parallel, 1 1, x x x x x. Now what is this? When two are in series, what you write? Both are identical, therefore what? X by 2, half of it. Here x plus x plus x, 3x. Therefore x is the common factor. Half plus 3 x. LCM is 2. 1 plus 3 into 2. Therefore x 1 plus 6 by 2. Therefore x 7 by 2. X resubstitute in this combination. Therefore resistance of this combination, this configuration is 1. X is 1 by 5 into 7 by 2, 7 by 10, or 0.70. Therefore for this combination, resistance of this combination is 0.70. Now somebody else can think in this way also. Can I do like this? There are innumerable possibilities. What is this? Two x is parallel to x. This is in series 2x. 2x into x, product divided by sum. 2x plus x plus 2x. 2x square by 3x plus 2x. X will cancel. 2x by 3 plus 2x. Then 2x is the common factor. 1 by 3 plus 1. 2x. 3 is LCM. 1 plus 3. Therefore 2x. 4 by 3. I'll write it here. This is second configuration or second arrangement is 2x by 4 by 3 or 8x by 3, 8 by 3. X is what? 1 by 5. Therefore 8 by 15. Again 8 divided by 15. You will get around 0.533. See here 0.7, 0.55. There is a lot of arrangement, quite a lot of arrangement. See, in fact, I also don't know, just when I start doing, I am getting a lot of thinking. This is the one way. Another possibility is also there. All three in parallel. 3 is parallel, 2 is in series. And these also possibilities. X. This is one possibility. X. Okay. Innumerable possibilities are there. And this is also another possibilities. This is same as this. What? See, this side and these two are in series. This is parallel. This is same thing, same value you will get it. Therefore, if you start thinking, you will get a lot of ideas. This is like a game you have to play. Therefore, arrangement of the series, this multiple choice question, it depends upon your way of thinking. The how you do the problem at that given time, that idea is important. Therefore, it requires a lot of practice. And there is another question they have asked, the multiple choice question only. But it's very simple. Here, what is 1 coulomb? What is 1 coulomb? It is unit of charge. You know this. Now, rate of doing work is called what? Power, because power is work by time. Rate of flow of charge. What is this? Rate of flow of charge? Flow of charge, T. Rate of flow of charge is called current. What is the unit of power? Watt. What is the unit of current? Ampere. Define 1 ampere. 1 ampere is what? When 1 coulomb of charge flows in 1 second, the current is said to be 1 ampere. Then what is the work done per unit charge? Work done per unit charge is called potential or volt. Volt is equal to work done by Q. Volt is what? How to define 1 volt? When 1 joule of work is done, when shifting 1 coulomb of charge against the field direction, the potential difference is 1 volt. See, suppose if potential difference is different from potential at the point. Potential at the point is 1 volt. Here potential difference is 1 volt. What is the difference between this? From here, from A to B, I shift 1 coulomb of charge. If I do the work is what? 1 joule. It is a work done in shifting a 1 unit charge, that is 1 coulomb of charge from one point to other point against the field direction is 1 joule. Then the potential difference between these 2 points is said to be 1 volt, right? What is potential at this point is 1 volt. Potential difference is 1 volt. Potential at that point, it is what? It is a total work done. This is a total work done in bringing a unit positive charge from infinity to that point against the field direction. Field direction is this direction. Therefore, total work done in bringing a unit positive charge from infinity to that point against the field direction is called, against the field electric field direction is called potential at that point. Therefore, you have what is that? Then ask, write the formula for heating effect. Heating effect is what? I square R and T. Heating effect depends upon the heat generated is directly proportional to square of the current, resistance of the material, time during which the heat is passed. Therefore, they may ask you for match the following also. Current. Current is what? What is current? For current, 1 coulomb, what is that? Ampere. Ampere is 1 coulomb per second. A resistance, unit is ohm. Resistance is what? V by I. Or how to define 1 ohm? 1 ohm is what? 1 volt by 1 ampere. When 1 ampere of current flows through the conductor, which is maintained at a potential difference of 1 volt, then resistance of the conductor is said to be 1 ohm. Power, all these things you know very well how to define it. Define unit of current. Which is the unit of current? 1 ampere. Unit of current is 1 ampere. How to define unit of current? This is unit of current. Unit of current. This is 1 mark they'll ask you. When 1 coulomb of charge flows through the cross section of a conductor in 1 second, 1 ampere of current is passed through the conductor. Now they have asked us what is that? How many number of electrons in 1 coulomb? In 1 coulomb. Number of electrons is 1 coulomb by E. That is 1 coulomb by E. Electronic charge is 1.6 into 10 to the power of 19 coulomb. Get cancelled. Therefore 10 to the power of 19 goes up 1.6 or what? 10 into 10 to the power of 18 by 1.6. And you know what is the value of 1.6? 1.6 divided by, sorry, 10 divided by 1.6, we got 6.25 into 10 to the power of 18. So many number of electrons. This is for 1 mark they have asked. See, potential difference is measured. Potential difference is measured across any any element that is called a resistor. Resistor is what potential difference is measured is parallel. That means the voltmeter is the instrument which measures the potential difference. For a battery also, if I want to find the potential difference, I will connect a voltmeter. It should be connected parallel to the battery or a cell. For this is called battery or cell. If I want to find the terminal potential of the potential, I have to connect the voltmeter parallel to the resistor. Now this is what is that 1 mark they have asked. See, this particular sum is very this type of questions are all very important. What do you mean by potential difference? Is 1 volt. If 1 joule of work is done in moving 1 coulomb of charge from one point to other point, 2 point, against the field direction of the part, then the potential difference at the point is said to be 1 volt. Potential at the point is total work done in bringing unit positive charge from infinity to that point against the field direction. If I spend 1 joule of work in shifting a unit positive charge of 1 coulomb from infinity to that point against the field direction, by doing so I will spend 1 joule of work, then potential at the point is said to be 1 volt. Therefore, be careful about this. Potential at the point, you write one definition. Potential difference, different. What is that? Different definition. See here, sometime they ask you some problem on this, right? What does it mean by, see here, how much energy? Work is nothing but work done is equal to energy. If you have energy only, you can do the work. They may ask you how much energy is given to each coulomb of charge passing through a 6 volt battery. This is a 6 volt battery, right? The battery is having a resistance. This is called internal resistance, they call it. This is called internal resistance. Therefore, what? 1 coulomb of charge, that means electron flow from what is the negative to positive. Current is said to be moving from positive to negative. Now the question is what? 6 volt battery, and I am shifting 1 coulomb of electron. I am shifting 1 coulomb of electron inside the battery. The battery voltage is what? 6 volt. Now how much energy is given to 1 coulomb of charge? Each coulomb of charge passing through the battery. Energy is how much? Work done per unit charge is equal to potential. Your potential is how much? The potential is 6 volt. Work done, charge is 1. Therefore what? 1 coulomb. Therefore work done is equal to 6 joule, or the energy is equal to 6 joule. The answer is 6 joules. You have to work it out very fast. Therefore work done is equal to Q into V. I am shifting 1 coulomb of charge to the potential difference of 6 volt. What is the energy I spent is what? 6 joule. If you shift to 5 coulomb, 5 6 are 30 joules. Like that, they may change the sum. Therefore, multiple choice question, you have to be very, very careful. Unless or otherwise, if you know the fundamental, you can't do that. Right? Then, what are the factors? See, we have done it. Resistance, so many sums we have done on that. See, resistance directly proportional to the length, resistance of a material inversely proportional area of the cross section, and resistance is of a given material directly proportional length and area of a cross section. And if you equate, you will get some constant L and A. This is the constant is called specific resistance or resistivity. Now, therefore, what are the factors? Factors on which the resistance of the conductor. Resistance of the conductor depends on. It depends upon length. How it is depend? Directly proportional to length. That means more the length, more the resistance. And it depends on area of cross section. How will it depend? Inversely proportional to area of cross section. If area cross section less, resistance is more. If area cross section more, resistance is less. This is the way related. And it depends upon the material of the substance. That means copper having low specific resistance, aluminum low specific, wood high, some metals, some alloy have low. Therefore, it depends upon the nature. Another thing is what? Resistance depends upon temperature. When the temperature increases, resistance also increases. So does the specific resistance also increases. Specific resistance increase on temperature. And what type of resistor these are called? Linear resistor. We call it is called linear resistor. What are linear resistor? Linear resistor obey Ohm's law. It obeys Ohm's law. That means you'll get a line. If you plot current versus voltage, you'll get a straight line. And what do you mean by the slope? Slope is what? Opposite by adjacent. This is, then what is slope? Slope is equal to tan theta opposite by adjacent, and V is equal to IR. This is the mathematical form of Ohm's law. What is mathematical form of Ohm's law? Voltage is equal to I into R, where I is the V is the voltage, I is the current, R is the resistance. Whenever there is a change in voltage, there is a corresponding change in current. R remain constant. Then I substitute here. When I substitute here, slope equal to delta I by delta V is equal to delta I R get cancelled. Therefore, slope is equal to 1 by R is equal to 1 by slope. Reciprocal of the slope is equal to resistance. Reciprocal of the slope of IV characteristics. IV characteristics gives slope. Therefore, these are the detailed things. See, this is 1 mark. Mathematical form of Ohm's law, 1 mark. Resistance is reciprocal of slope of IV character. This is 1 mark. And several questions they have asked on this. What are linear resistor? Which obeys Ohm's law. What is specific resistance or resistivity? Is it same? One and the same. What are the factors resistance depends on? Depends on length. How? Directly proportional. More the length, more the resistance. That means bigger the diameter, lesser the resistance. Right? Thin wire, more resistor. Therefore, like this, they can ask you all possibilities. Right? And therefore, you just always be alert, and line to line you have to read. Okay? See the question also. Another question also there is. Here what area? A thin wire, a thick wire. Which wire current easily flow? Right? Thick wire only. Because the resistance is less. Why resistance is? Area of cross section is less. Therefore, thick wire and thin wire. Here thin wire resistance is more. Therefore, will current flow more easily through thick wire or thin wire of same material? Material is same. The question, when when they are connected to some source, this is for multiple choice question. They ask, what is your answer? Material is same, thin wire, diameter is small, resistance will be more, thick wire, diameter is more, resistance less. Resistance is inversely proportional to area of cross section. This is the idea behind it. Therefore, multiple choice question, you can use it. Okay. See, now keep revising it, otherwise you will not get the fluency. Is very, very important. Like how we speak our language or mother tongue or the English or whatever the language you speak. That much fluency you must have in that subject. Right? Anyway, please discuss with your friends. If you have any other ideas, just teach to us also. Each one is our principle, and discuss with your friends, your teachers, and suggest and give your constructive comments, and ask maximum children's or students to subscribe. It is not the business motive, it is purely a social service by lot of teachers from Vijaya College, National College, MES, and many colleges. Those people are contributing, and be thankful for all those teachers and their managements. Indirectly, they are helping. When you help for others, you should not give your identification. Always help and let our society become fully knowledgeable, and now full knowledgeable youngster come in future, and we make our nationalism more powerful than any other country. Thank you. Jai Hind.